Well, hello, everybody. Distance learning meets construction and maintenance and all sorts of stuff. So that's become musical classrooms for me. I'm meeting you today from Mr. Caravez's classroom, since every other room that I've tried seems to be having some issues. So here we go. We're going to take a look at everybody's favorite topic. I know that it's been such a long time since we've got to study particle motion, and I know you're so excited about that. So we're going to actually go back and take a look at a question that I can actually pack into a very, very tight little space, and it's a pretty nice little question. So we're going to go ahead and check out the 2011 problem number 1. And because it says problem number 1, I do want to remind you that anytime that we're talking problem 1 or 2, we're talking a calculator optional question, which generally means kind of more like calculator required. In other words, don't waste your time doing formal derivatives. If it's asking you for a numerical answer, just take your calculator and do an inderiv. Or if it's asking you for an integral, just do an FNINT. We can set that thing up, but we don't actually have to go through the formal way of doing this stuff like we normally do. It's mainly about setup. So we're going to go ahead and jump in here and take a look at this little question here. So this is our particle motion. We have a particle, and notice it says for 0 to 6. A particle is moving along the x-axis. So this is just simply moving back and forth along a line. Particle motion x of t is not explicitly given. The velocity of the particle is given here. So notice we have the velocity, not the position function, and the acceleration. That's crazy. They actually gave us the position and the acceleration. We could have totally done that. We didn't actually need them to tell it. We could have done that derivative. We know how to do that. That chain rule that's sitting there. They're asking me, though, in the very, very beginning, we have all that, and we have an initial condition given right here. So in part A, they ask, is the speed of the particle increasing or decreasing? So keep in mind, it doesn't say velocity, it says speed. So remember when we dealt with that stuff before, I'm in a different room, so my camera is in a weird spot. There we go. So remember, if the speed is positive, that means that we would need both the velocity and acceleration to be negative, or both the velocity and the acceleration to be positive. Either way, if they're the same sign, then we know that it's going to be speeding up. And if they're different signs, we know it's going to be slowing down. So I'm just going to say A of 5.5 equals negative 1.358. V of 5.5 is negative 0.453. Please notice I'm not going to justify that at all. I grabbed it off of my calculator. I made this one y1, I made this one y2, and I just used the value feature. So I'm just going to make this little statement that says since, and I notice, and as I'm grading some of you, you want to do a little bit more writing than you have been doing. Sometimes you might not get all that credit because they want you to actually express your thought processes. So since A of 5.5 and V of 5.5 are of the same sign, notice S-I-G-N, not S-I-N-E, they're of the same sign, the particle is speeding up at t equal 5.5. All right, moving on. Now it says, let's find the average velocity. Well, it doesn't say average value, but that's implied by the way they say that. It's the average value of the velocity of that particle from 0 to 6. And what you want to remember is that the average velocity would be using that average value function. So it'd be the integral from 0 to 6 of v of t dt. Now that would be the total value, but then I need to go 1 over b minus a, which is 6 minus 0. So literally all I have to do is go into my calculator, tell it to do an FNINT from 0 to 6 of my y1, and let's get that answer and divide it by 6. I got 1.949, and I'm done. That was literally that easy. I'm just going to do an FNINT, make life really easy. Part C, it asks for the total distance traveled by that particle. Now, we should remember that to find the distance traveled by a particle, that means we need to integrate that velocity to go back to position function. but it's not asking for position, it's asking for total distance. So what I would do is I would integrate from 0 to 6, not a v of t dt, but close. I want to throw an absolute value of that. So keep in mind that as I do that particular work, you have to know that in my calculator, I'm not going to, by the way, put this on the test. I'm not. But what I would do is I would do FNINT of the absolute value of y1 comma x comma 0 comma 6. And I would just let my calculator do all of that fancy mathematics. Remember, this is under math number to get the absolute value. And my calculator says 12.573. And you know, I always want to go, hey, what about the units? What about the units? And if I look back here at the original problem, I don't believe it ever tells me what kind of units we have, so I guess I'm just going to write units. So no big deal. Then we go to part D, and it asks me one last thing. It says, for part D, on that, the particle changes directions exactly once. Find the position. Now notice it actually doesn't actually ask the time. It says, what is the position at that time? So what we know is that x of b, where b is just some value, would be 2, because remember here we had an initial position, 0 was 2, plus the integral from 0 to b of v of t dt. Now notice this is one of those fundamental theorem of calculus ideas. Now, when we do all of that, it says that it changed directions. Well, when I actually graphed v of t, I found out that it crossed the x-axis, or 0, at exactly one time, which is t equals 5.196. So that means what I would do is I would set this from 0 to 5.196 of v of t dt. Now, I would store this as a letter, B or A or something like that. And so then when I did my FNINT of y1 comma x comma 0 comma b, again, I would allow my calculator to do. Notice I'm not writing this on my test because this is technology speak. It's not math, but we do need to know that technology. And anyway, what that gives me is a total answer of 14.135 units, which means that it passed further to the right. It doesn't even mean that I have to say that. They don't require me to make that kind of stipulation. But hey, that was a pretty quick question. We got it all done. That's one of the fastest questions we've had. Anyway, because it's all calculator based, we don't have to show all of that stuff. We just have to know how to set it up and make it happen. Have yourself a great day. We're going to take a look at another one. It's probably a touch harder in a little bit, but hopefully that was pretty easy.